share screen. Okay, online audience, let me know, thumbs up if you're seeing the screen. So, Kaben, is it okay if you stand like this so they can see you instead of behind here? And
That's
you
fine.
can use this with your right hand?
I can make it work.
Okay, thank you.
I need the mic.
Yes.
Okay. All right, thank you very much. This is my first opportunity to be here at this campus, and I have to say I'm pleasantly surprised by its beauty, by its location, and by the work that you all are doing here. So thank you very much for allowing me a platform to come and talk about what we're doing. Hopefully it's an educational opportunity for everybody, as I have learned so far. So what I'm going to talk about today is something we call SEBA. Okay, and you may have noticed that it's pretty close to CEA, but we threw in a B. Okay, SEBA is a term that we coined for controlled environment biological agriculture. Most of the presentations, if not all of the presentations that you've seen yesterday and today, deal with a hydroponic nutrient delivery mechanism, meaning that some type of synthetic fertilizer is being utilized to cause those plants to grow. What we do is a form of aquaponics in which we raise fish in conjunction with our plants. I'll start out with a quote by Steve Jobs. The biggest innovations of the 21st century will be at the intersection of technology and biology. What controlled environment biological agriculture is, it's the cross-section of automated aquaponics and controlled indoor environments. Okay, the cross-section of aquaponics and controlled indoor environments. And hopefully by the end of this presentation, your understanding of what aquaponics is may actually be broadened a little bit. The most basic definition of aquaponics, it's a form of non-traditional agriculture in which we utilize and build recirculating water systems to raise both fish and produce. It's a combination of hydroponics and aquaculture, but in our opinion, it's better. And the reason why we think it's better is because it takes the best of both of those forms of agriculture and leaves aside the worst. So yesterday we had a presentation on hydroponics, and at the end of the presentation I asked a question, and that question was, what do you do with your excess waste? And the answer was we either dilute it and put it onto fields, or in the state of Arizona they actually take it to a sewage waste transplant system, because Arizona regulates that as wastewater, as defined by the EPA. So the hydroponic output solution is always going to be an issue. It's always going to be an issue towards sustainability. Okay? Also with hydroponic vegetables, especially fruiting crops, most customer satisfaction surveys all come back the same, with hydroponic tomatoes tasting not as good as a soil tomato. Whether this is perception or reality, it's a stigma that gets passed along with hydroponic tomatoes all across the country and all across the world. So what do we do with aquaponics? Well, aquaponics, we use fish, and the excess buildup that we have from our fish waste, we backwash out of our system with mechanical bead filters. We run it through an aerobic process where we add oxygen for 30 days, and then we add that waste back into our system, really closing that waste loop, which is a big advantage in my opinion. Additionally, because we're using a bio-based nutrient, the Brix levels of the crops that we grow are oftentimes elevated compared to that as to what you get at the grocery store. So what we've done by creating a biological system is we've taken the good from hydroponics, the ability to control, the ability to grow at a faster rate, the ability to put it in a controlled environment, and we've taken the best of aquaculture, raising a protein source in an integrated system. And we've left the worst. We've got the good taste, and we reuse and recycle all of our waste. Why aquaponics? It's extremely resource efficient for water and for space. Much like hydroponics, the water can be recirculated. It can be used over and over and over again. The big difference in hydroponics and aquaponics is that aquaponics relies on a beneficial bacteria, actually multiple beneficial bacteria. We're getting a little feedback. What that beneficial bacteria does is it converts the fish waste from ammonia to nitrites and then to nitrates. And it's the nitrates that are consumed by the plants. Without that beneficial bacteria, you don't have aquaponics. So what I always tell people is you're not farming fish and you're not farming plants. What you're farming is beneficial bacteria. I'm from Oklahoma. I know, you guys boo hiss, right? I think we can all agree that Texas. History repeats itself, and history is repeating itself currently. This is a picture of the Dust Bowl. Started in Oklahoma due to bad agricultural practices. And I, as an Oklahoma farmer, have to own that this happened on my family's watch. And it was these lessons that my grandfather taught my brother and I that enabled us to look at agriculture from a more sustainable method. Okay, I like to joke, there was a Will Rogers joke about the Dust Bowl, and it was literally the only good thing that came out of it. And he was waxing philosophical, and he stated that when all of the Okies left Oklahoma to go to California, that was the only time in history that both states got smarter. So I always thought that was pretty good. Okay. He was right. Yeah, I can agree with that, right? Hey, but I don't find it absurd. I don't find it surprising now that you're seeing these same issues in California, right? Because all that happened was that farming technique left Oklahoma and went to California, and water wasn't valued, and we ended up in the very same position in California that we were in Oklahoma almost 100 years ago. Okay, so why SEBA? Well, number one, it can provide consistent year-round production regardless of climate conditions. It's something that can be picked up and moved to any location anywhere in the world because its principles are geared around indoor production under artificial light. Greenhouse production is great, and mind you, there are many greenhouses spread about the country and about the world. But the problem with greenhouses, as they were addressed yesterday, are the inconsistencies, the different design types, the different shapes, the different widths, the different lengths, the different orientations, the different climates that those greenhouses are in. All of that creates a barrier for uniformity, for research scientists, for farmers, for anybody. We can't control when the sun shines. We can't control when the clouds cover the sun. Those things are all out of our control in a greenhouse. In an indoor grow environment, everything is based upon set point control. And that set point control can truly enable you to find that optimal point for your plants and for your fish. In my opinion, we should be using indoor environments to optimize and then going to greenhouses and working that way. Taking what worked optimally in an indoor environment and then applying that to a greenhouse instead of trying to figure out what's optimal in a greenhouse. Another thing about SEBA is it's organic certified. We were the first company after the National Organic Standards Board made the recommendation to the USDA that aquaponics, hydroponics, and aeroponics can be certified organic as long as they meet the minimum standards. We were the first company nationwide to meet those minimum standards. And our farms are scalable and they're replicable. The organic crowd got upset with us at a conference and they said, "You build organic farms that can be put on trucks and driven down the street." I said, "You're right, that's exactly what we do." The big benefit to this replicable and scalable technology is most organic farmers have to wait for the land next to them to go for sale. Then after that, they have to wait a 3-year period before they can get that land certified organic. What this does is it prevents an enormous scaling issue for most organic farms. With our technology, that scaling issue goes away. This is a SEBA operation in Oklahoma. The company's called Sooner State Wellness. This building here is about a 10,000 square foot building. Okay, the entire operation is built out with about 9,000 square foot of conditioned space. Okay. Indoor growing starts with the environment. So what you see here is an agronomic IQ air handler. You see it's got 2 tiers. The 2 tiers have a built-in redundancy to where if anything goes wrong with one of the units, it's able to still function and run off of that redundancy until we have time to get to the unit to service the unit. If you'll see the little screen right above the agronomic IQ label.
Can you use the mouse?
Oh, thank you. You see the screen here? This screen provides us with set point control on temperature and humidity. And depending on what plant we're growing and depending on what stage of growth that plant is in, that set point control provides us a perfect environment. Take trying to propagate or clone. You want to have a higher humidity and a higher temperature, the 80-80 rule. Take when a plant is in flower, you want temperatures to be about 80 degrees, but you want your humidity under 60 because that's what can encourage mold to grow. Take at harvest, you may want to lower your temperatures in order to have some more color expression in your plant. Okay. All of that can be achieved with this set point control. If you see back behind the unit, these walls are structural insulated panels or SIPs panels. It's essentially a piece of styrofoam that has that fiber pressed on both sides of it. It makes it an incredibly good R value and also makes construction very easy because there's literally just seams where these panels slide in together. Here's where we get a lot different from most people. Okay, this area here is our aquaculture room. This is our nutrient generator for the entire facility. You've got 2 1,000-gallon fish tanks, a 425-gallon sun tank, and over here is the mineralization tank that I was talking about. We strip all of our excess solid nutrients with this mechanical bead filter, place them into this tank with aeration for 30 days before adding them back to the system. It is a zero waste, zero water usage system. The only time we lose water is when plants consume it or when it transpires. Okay. Here's an example of one of the grow rooms. You'll see on the wall over here, you have your controller panels. I'll be able to talk a little bit more about those in a second. But you have individual grow media beds planted with 16 to 20 different crops under LED lighting. The LED lighting also has set button control to control the different spectrums for different stages of growth of the plant. And now here's where the rubber really meets the road. Okay? This is our automated nutrient delivery mechanism. So if you look over here, that's essentially what you would see right here. We have mechanical actuator valves and ultrasonic sensors that communicate with one another through this communication box. What's happening here is we're able to set different fill heights and different drain levels. We're able to flood individual rows and disable other rows. What this does is it gives us full control over how often a row floods and how often a row drains. When you couple that with changing your feed inputs, our goal is to develop biological programs where you can grow any crop aquaponically. Water usage. The first year that we filled up the system was in 2018. Over that year, we used 3,685 gallons of water for 1,220 square foot of grow space. This included the initial water that went in to fill up the system. Approximately 3 years later, we're using under 2,000 gallons of water a month. That breaks down to about 0.06 gallons of water per square foot of grow space per day. And this is growing a fruity crop. We don't know of a more water efficient system. Okay. As you see, we're actually getting a little bit better too with our crop production. As anything, moving into a new environment, moving into a new growing system, there's some learning curves. But on our last harvest, we're pushing almost 2 pounds per light, or if you're looking in terms of dry weight per meter square, about 0.07. Key production factors for our aquaponics system are going to be our lighting. You see our LED lighting, temperature and humidity. carbon dioxide levels, and then fish feed dosing. The fish feed that we use is called optimal fish feed. The cool thing about optimal fish feed is it has the micronutrients and macronutrients built into the feed. So what happens is the fish consume the feed, they pass those excess nutrients through that biological process, and the plants are able to consume those excess. That's how we maintain that organic certification. Here's some current SEBA projects. This one is one I'm incredibly proud of. This is actually an aeroponic nutrient delivery mechanism. So if you see here, we have our fish tanks. If you see here, that's all right, we'll work through it. If you see here, you'll see a mechanical bead filter, and you'll see the sump tank. Okay, this is a low pressure system. The aeroponic nutrient delivery mechanism requires a high pressure system. So we utilize a booster pump. We take the water, we propagate our clones in these beds, we move the propagated plants over to these beds where we mist the aquaponic waste. This has allowed us to eliminate all grow media and has also enabled us to do high density planting, where the only negative space is 30 inches in between whatever row you're working with. Additionally, our racking systems enable us to build 2 different tiers, which we think will be the next evolution of our technology. Here's another system. This system is actually going in a greenhouse in Lockhart, Texas for fresh herb production. And it's utilizing the grow media style automation system. So what we do a little bit differently than almost every other aquaponic company is our standardized scalable approach. We can draw your farm on a 3D CAD model and allow you to see what that farm looks like before we ever give you a quote. We can tell you down to the individual piece of PVC what your system is going to look like and how much it's going to cost. And what this has done is it's taking the unknown out of the aquaponic design industry and has really enabled us to sell a lot of these systems in a very short period of time. So, if you all have any questions, I'd like to point out my team that I have here with me. I've got Regina, Dr. Regina Cook in the back. She has her PhD in public health and has really geared the company towards education and making sure that we're meeting our social check marks. Okay. We've got Josh Ducey over here. Josh is a recent hire who graduated from Kentucky State University with his master's in aquaponics and in aquaculture. So he's our fish expert. My background is law and business. I'm a JD MBA from Oklahoma. Also taught economics at Eastern Oklahoma State College for a good while. With our team, we're incredibly diverse, we're incredibly well-rounded, and we take a multidisciplinary approach to making sure that our growing systems meet your needs. So if you have any questions, please feel free to come to our booth or reach out to me at this information. Thank you very much.
Thank you.